Okay, I believe this is the last video for the week. Is science. The best for last. Always see the best for last. F12 through 23. We've been doing a little bit of a review with solid, liquid, and gas, only because it comes up in our book earlier in the year when we talk about water. So 12. So the same principles that we can apply to water can apply to other materials. Other things can be frozen, or other things can be turned into a gas. This should be really stinking familiar. Excuse me, talking too fast. Comparing solids, liquids, and gases. Our words are solid, liquid, gas, physical change, mixture, and solution. This kid over here is making oobleck. Oobleck is not quite slime. It's a little more goopy, but when you punch it, I don't think it budges. So is oobleck a solid or a liquid? It's technically a plasma. It's got qualities of both. Alright, how can you classify matter? We're not going to read all this because you know it. Solid, liquid, and gas. A solid has a definite size and shape. A liquid has a definite volume, but it does not have a shape of its own. It takes on the shape of its container, like this juice glass. I could put liquid in this balloon and it would be the shape of the balloon. But typically I fill a water balloon. Most of the time when we see a balloon, it's filled with gas. Gas has no definite shape nor volume. It takes the shape of its container as well. So solids are packed together rather tightly, dense. Liquids are looser packed than a solid, so they are less dense. And gas is the most loose. They just kind of fling-flong around their container. How can matter change? This is new. So, we're talking about a physical change. Okay, some of us are waiting desperately to get a haircut. A haircut is a physical change. I did not make the hair a different substance or a different item. I just made it look different. Now, if you're a girl or even a boy and you color your hair or highlight your hair, or put a perm in your hair, you're adding chemicals. So that's a chemical change. But just a cut is a physical change. So this lady is making origami. When she folds the paper, it is still paper. So that is a physical change. Matter can change but still remain the same. The paper below looks different, but it is still made up of the same particles. She cut it into as many pieces as she would like, and it's still paper. Paper's paper. Same is true when you make a wooden model. As you cut and sand the wood, its size and shape change. The wood is still wood, but it is still made of the same particles as well. A physical change is a change in how matter looks, but not in the kind of matter that it is. The kind of matter stays the same. Sifting, sanding, and pounding are examples of physical changes. So anybody that carves something or cuts into something is making a physical change. Matter can change state. You can find water in the solid state, liquid state, or gas state. Water looks very different in each of those, but it is still water. Ice is solid. It can melt. Melting is a physical change. Water can also change to a gas, which is evaporation. When water vapor cools, it loses the energy that it gained as a liquid, and it condenses. It becomes a liquid again. When it cools enough, it freezes. Ice is a solid. So melting and freezing, condensing and evaporating are physical changes. So anytime water is changing its state, it is changing in physical change. You can check out that chart. And I did kind of fly through this page because I know you know the material. This is new as well. Can you mix different kinds of matter together? Absolutely. Okay, when you mix different kinds of matter together, you make it a mixture. In a mixture, the properties of each kind of matter do not change. Do not change. Lemonade is a mixture of lemon juice and water. Fruit salad is a mixture of many kinds of fruit. Pick out a piece of orange from a fruit salad, it is still an orange, and the salad is still a fruit salad. Mixtures can be of any combination of solids with liquids, solids with solids, solids with gases, or liquids with gases, or liquids with liquids, or gases with gases. Air is a mixture of different gases. If you pour milk in your breakfast cereal, you now have made a mixture of a liquid and a solid. Check this out. Mom, I did pick it up, but you put it all into one bowl. I want the things that are separate. How can we separate the rice from the marbles from the paper clips? Well, if the strainer had a little bit bigger hole, the rice might go through it. If the paper clips are metal, they would be magnetized. It might be quite a project. Okay, so a mixture. So if I put together a bunch of stuff in my bag, my purse, that's a mixture. If I make Chex Mix, I have made a mixture. The opposite of mixture is solution. Now this is what we probably see them both pretty equally. Sorry, I hit the microphone there. We probably see them both pretty equally, but a solution is harder to understand, okay? So in a solution, you have to dilute something. So if I put salt in water, or not this picture, it's sugar in water, Kool-Aid powder in water, I dilute the water to also include the salt or the Kool-Aid packet, and it changes the color of the water. If I'm making sweet tea, the sugar, I want the sugar to be from the very top of the pitcher to the very bottom. Sometimes when it doesn't get stirred very well, it's really sweet at the bottom. So that's a solution. Something has dissolved. What dissolves in sweet tea? The sugar. It's no longer in those little crunchy particles. Now it is diluted and it is part of the water particles. Okay? So a solution forms with one or more kinds of matter are mixed evenly into each other. Making a solution is a physical change. Salt water is a solution. If you mix the two, you'll no longer see the salt particles as long as you have enough water. The salt is still there, you can taste it, but it's not visible as long as you have the mix correct. I mean, if you put a cup of salt and only a tablespoon of water, obviously that's not going to dissolve all the salt. If the water were to evaporate, the salt would be left behind. Not all solids form solutions in water. Try to mix sand with water. This is why I was covering this up a while ago. Sand with water is not a solution. The sand particles will not dissolve. Why? Because they're rocks. The sand is just going to sink to the bottom. Some things fall to the bottom no matter how long you stir them. They won't dissolve. Some solutions contain no liquid at all. Air is a solution of different gases. Steel is a solution of several solids. And it is used to make cars, bridges, and buildings. Well, that's confusing. Air is a solution. Air is a mixture. Why do you think air is both? So the gas particles are going all over the place. Sometimes they combine. Sometimes they stay separate. When they combine, it's a solution. When they stay separate, it's a mixture. Certain gases don't bond together to one another. Check out this taco. Alright, here's your quiz. Is a taco a mixture or a solution? I'll wait. Oh, y'all are too good. It's a mixture, yeah. Because I can pick off the tomatoes and the cheese and the lettuce, which, you know, if you don't like certain things, that's what we do already. So a hamburger is a mixture. A chicken sandwich is a mixture. Things that you can't unmix, like soup or a cake, those are solutions. So foods such as salad, pizza, and tacos are mixtures. You eat and drink solutions too, like orange juice and hot chocolate. Those are two solutions. All right. So this is real life stuffs. It's a little bit about plastic and how it's made. It is overtaking our Earth. Oh, it's so sad. So sad. So sad. Wasuwusu, wasuwusu. In your envelope, you had a packet. It had all these things in it. Okay? It is a review packet for this chapter and one of your last grades for science. Follow the directions. Every page has a different set of directions. Color the simple machines. You may have to look back in your book to find the simple machines that these kids are playing on. Match up. I want to point this part out of the page because every year the kids seem to miss it. I know you guys won't though. This is the key, the code that I want you to use to tell me if each item is a certain type of machine. So like the skates have a wheel and axle, so you put number 5 because that's what wheel and axle says. Okay, all the way down. Now this is a more complex machine. You might have more than one answer. Word scramble. All your words are down here. Like this one, it says R-E-L-E-V. The answer is lever. Okay, you can do that. Word search, because that's my favorite thing in the world. You know what's good about a word search? It checks your visual acuity. It checks how good your eyes are working. Also, if you can spell. So you can find these words that are down here at the bottom up in this area. There's one right there. Cool. I gave you a free one. I couldn't help myself. I had to find it. Okay, and then this is a page I want to do together because we just talked about this in your textbook. Mixture or solution. I love this page. I created this page. This is my baby. Well, one of my babies. I got a ton of babies. Mixture or solution. Identify the following items as mixture or solution. Fruit salad, lemonade, salt. No. Okay, fruit salad is a mixture. Can I pull the strawberries away from the oranges? Yes. Lemonade with sugar. I put the lemonade in, I put the sugar in, and I stirred, and then I gotta go drink it. Do I have to crunch through sugar particles? No. So it is a solution. I dissolved the sugar particles. Salt water. It's the exact same as the lemonade solution. No, you cannot abbreviate. I want you to write the words. These are new words. Sandy water. That one was in our book. The sand, no matter how much I spin it and stir it and shake it, will not mix. It will not dissolve. Kool-Aid. That was an example. Solution. It is just like lemonade and salt water. It dissolves. Oh, I like this one. Mac and cheese. Okay, so I have the macaroni noodles and I have the cheese. Can I separate the macaroni from the cheese? Yes, you can wash the cheese off. I love arguing about this one though. This one's a mixture. I can wipe the cheese off. Nobody wants to do that. Eat your mac and cheese. Sweet tea. It's the same as the other drinks we've talked about. Solution. Good? Alright, this one was in your textbook. Cocoa Puffs with milk. Mixture. I can pull out the Cocoa Puffs. Tell me about the milk. If the Cocoa Puffs have sat in it long enough, what happens to the milk? Yeah, it turns chocolatey. It is now a solution. But the cereal with the milk is a mixture. If I remove the cereal, it gave off chocolate particles and combined with the milk particles, and now the milk is a solution. Aha. Trail mix. You said it right there. Mixture. Cake batter. Oh, remember me telling you? If you make a cake, I put on all those solids like the salt and the baking powder and the banana or the strawberry, whatever flavor cake. And then I stir And then once I stir it all together, I can't take anything out. If you cannot remove the individual items, it is a solution. Something has dissolved. Oh, gasoline. I love this one. Okay, gasoline that you put in your car is not pure. It's a lot like cake batter. No solids are in it though. But there are chemicals that are in gas form and there are liquid chemicals. So it is a solution. Today's gasoline is not the same as the gasoline that was being produced 5-10 years ago. Now sometimes they add alcohol or sometimes they remove alcohol. So it is a solution. You can't go and get the vat of gasoline and go, oh, particle, oh, particle. And they're all mixed together. And then Coca-Cola and all of its sugary goodness is also a solution. Okay? Alright, so we did this page together because I want to make sure you got your understanding of mixture and solution. And I would also like to do this page with you because I like it. And we are in May now. May the force be with you. Decide which force you would use to do the following tasks. Right? Push, pull, or both. Okay? Open a door. How do I open a door? Well, I can do this way. Oh, what if I'm going inside? I can both. I can push and pull a door. Tow a car away. So the car's stuck in the mud. I'm gonna pull. And it says away, so this one's pull. Shut a door. Well, if I can open a door both ways, can I shut? See, my closet door goes this way. That's a push. But I could also be in the house and shutting the door this way, so both. So I pushed the closet door and I pulled the garage door closed. Put your shoes on. Oh, I love this one. Alright, if you don't believe me, you can go get a pair of shoes here in a minute. Preferably shoes with like tennis laces. Put your shoes on. Okay, how do you get your foot in it? You push your foot into it. But what do you do with the shoe? As you push your foot in, you pull the shoe. So this one is both. Okay, and I usually do this one in the classroom with you, and I show you all of these activities. So sharpen a pencil. So I'm going to push my pencil into the sharpener and I gotta pull it out. So sharpen a pencil, push it in there and pull it out. What if it was a manual one? Okay, I gotta push the pencil in there and pull it out. What am I doing with my wrist? I am pushing the dial, the handle, and pulling it back. So this one is also both. Okay, cut with scissors. Okay, how do I open the scissors? Pull. How do I shut the scissors to make the cut? Push. But then how do I make the next cut? Pull, push. So this one needs both. Play on a teeter-totter. It doesn't say if you're the fat kid or the skinny kid. So you're on a teeter-totter and you want to go up. So you would push. What do you do with your hands to make sure you don't fall? Yeah, you got to pull on the handlebar too, right? So you got to pull on the handlebar and then you got to push it back down. And you do the same thing with your feet. So if your feet are in the dirt, you're going to push off the ground and pull up the handlebar at the same time. And then when your turn is to go down, you're going to push the handlebar. You're going to pull the handlebar, sorry. You're going to pull the handlebar to you and then push your feet off the ground. So to play on a teeter-totter is also both. Climb a ladder, and see the reason most of them are both is because it doesn't say up, down, or away. The only one that says away is this one. Okay, climb a ladder. What do I do with my feet? I put them on the rung and I push down. What do I do with my hands? I pull both. I just really want you to notice that if you don't have the direction word, it's going to be both. Because forces are in pairs. So that's your key for this assignment. Forces are in pairs. So push and pull, up and down, back and forth. Move a chair. Well, I can push my chair back from my desk, or I can pull it toward, so both again. Now, if this had said move a chair toward a desk, it still could have been both. It depends on if you were standing or sitting. If you were sitting, it would have been a pull. If you were standing, it would have been a push. So really, it doesn't necessarily matter what the activity says in direction, except for away. The only way you can go away is to pull. Okay, that's the end of that booklet, but you still have other things to work on, and it is not due very a tight turnaround. You've got a while to work on this, okay? If you have any questions on your science, please let me know. Have a good weekend.